Aside from small projects, another frequently requested type of project is kitchen cabinets and so forth. Now, I don't have any projects lined up immediately for a kitchen project, but I do have a laundry room project coming up. So we'll go through the process, a very detailed process, of how you go about sizing the cabinets, working with the various dimensions, modifying things, the door panel sizes, just a lot of detail into the overall design and construction of making upper cabinets. Now, as I mentioned, these are for a laundry room, so they're not going to be very standard. I'm going to be modifying them to suit the function better than just using an ordinary kitchen cabinet. Now, I'll bring you in close, show you a couple details, and then we'll get about construction. Now, here's an overall concept drawing of what we're trying to do. As mentioned, these cabinets are for a laundry room. We've got a wash tub, a washing machine that's a top load, and then a front load dryer. Now, because of the top load washing machine, we need to have a little additional height here so that as you open the lid, it doesn't hit the bottom of the cabinets. Now, the other function that they wanted in this laundry room was to maximize their storage space. So rather than go with the short height or standard height cabinets, these are the full height, 42 inches top to bottom. So they go all the way up to the ceiling. The bottom edge is at pretty much a standard height. It's just that on the shorter cabinets, you usually have that soffit up above. Well, these just go simply all the way up to the ceiling. So we'll have two identical cabinets flanking a center cabinet that'll have two doors at the top and then just an open shelf area in the middle. Now, the dimensions, we'll be giving a number of them, but keep in mind that these are all somewhat custom. Now, here's one of the overall dimension drawings that shows the cabinets side by side and the various overall dimensions. Now, we will be going through a process further on down showing the different overlays of the cabinet doors. These are full overlay cabinet doors. They'll be raised panel, very traditional looking. Now, on the larger cabinets, we're going to do a 5/8 inch overlay. On the smaller cabinets, a 1 3/8 inch overlay. Only difference being that we wanted to demonstrate the two different variations there. Now, going back to this drawing again, one of the concepts that's different with the laundry room upper cabinet structure, the laundry equipment, the wash tub, the washing machine and dryer, they stand out further from the wall than a typical kitchen counter. Often you have the dryer vent hose and so forth, and other things back there, perhaps gas or power. And that brings this equipment forward about 6 inches further than the front edge of a lower cabinet, say in a kitchen. So to help make accessibility easier on these upper cabinets, they're about 5 inches deeper front to back. That'll give more storage in them, plus make it easier for accessibility. And that wraps up the details and overall concept. Now, the one thing I'd like to point out right away, I've ordered up the material a couple weeks ago. What was shipped in wasn't the right stuff. Basically, it's just maple plywood with a couple of good faces. You wouldn't think it'd be that tough to get, but I'm just having a heck of a time getting materials these days. I'm hoping this isn't going to set the stage for any more troubles along the way on the construction of these cabinets, because frankly, upper cabinets generally are a pretty easy project to go through. I got started on this project by focusing on the material selection, selecting grain patterns, coloring, and so forth. I'm hoping to go with a natural finish on this. That's the requirement. I could tone it a little bit to even out some of the coloring between the different boards of maple, but ideally we do want to have a natural clear finish on it. So I spent a couple of hours just going through the rough stock, trying to figure out which components I can get out of the various boards, working on the color matching, as I mentioned, as well as the grain matching. Now, I've taken it as far as I could at that point. Now I need to focus on getting the material prepped. Now, I'm using hard maple for this. My preference is always to work with soft maple, but because this is going into a laundry room or a utility room, it's probably going to be subjected to quite a bit of use and abuse. So that sort of kind of pushes us into that hard maple category. Now, hard maple has a whole bunch of problems with it with regard to milling and so forth, and it can create a lot of problems along the way. So hopefully this will be a good opportunity for us to highlight some of the solutions to those problems that you may encounter. Now the material I've got is a variety of shorts, or what are called shorts. Some are 3 foot, some are 4 foot, some are 5 foot. Often you can get these a little bit better priced than you can if you purchase 8-foot boards. And of course the widths are random. Now this last stack here that I've got on the table saw, they've got some twist in them, warp. They're in pretty rough shape, as you can see. And you could run these straight through on your planer, but what's going to go in warped and twisted is going to come out warped and twisted on the other end. And that just makes for a lot of nightmares in assembly and getting things to sit and flat and square up and so forth. My jointer is a 6-inch jointer, which is a common model for most home woodworking shops. And most of these boards are 7 inches or wider. So that leads me to the next step in stock preparation. I've got to take these nice clear wide boards and cut them narrow enough to fit on the jointer, because my next step is to go through and get one of the 2 faces flat, and that's going to be real critical for the rest of the steps. Now the warp and twist that I've got on these boards isn't real excessive, but it's enough to make me a little bit nervous. If it was very excessive, where it just simply would not be controllable doing the ripping operation here at the table saw, I would go over to the bandsaw and then rip them there, because if I'm dealing with warp and twist and the board's kind of wiggling along during the cut, the bandsaw isn't going to kick it back at me. The table saw certainly could. So that's one point I'd like to make right now. I'm going to be using the table saw, but my material's not really that bad. It's just maybe a 64th or a 32nd out with regard to warp and twist. So I've gone through, measured up how I can maximize the yield out of each of these boards, and now what I'll do is get them ripped up so that they'll fit the jointer, which is our next step. Now the function of a jointer is to flatten out stock, to put one flat, straight face on the material before going to the planer. Now, if the board has twist in it, in other words, if this end is vertical and this end is rotated one way or the other, as we pass it over the jointer, the natural tendency is we'll start out with this end leading, we'll have this end flat against the bed, get out to a certain point, and then we start transferring our feed motion over to this end. Now if it's twisted this way with this corner up, we're going to end up putting this end flat, which would lift that far right corner up. Then we would get this surface. So what we'd end up with is still a board that has twist in it, but at least the faces would be smooth. That's not what we're trying to do with this tool. We want this surface to be flat and straight. Now if the board has cup in it like this, or bow in it rather, and we lay it down and it's not touching in the center, you can start with the board at the center, feed across, come back, feed across again, and remove your high spots. And that's the whole function of a jointer. We have to remove the high spots and work our way down to the low spots. That's how we work with this tool. Now, there's some folks that really promote the use of hand tools, and I myself really don't care one way or the other. But when it comes to hand planing and hard maple, it's not one of my favorite tasks in the world to do. So I like my power tools. Now what I'll do is go through and get one face cleaned up at least about 70 to 80% where it's good and flat. After I get the board passed over the jointer where I think it's good and flat, I'll go over to the workbench, lay it on there, check it, and then I'll know for sure if it's flat enough to go on to the planer. Now here again I can kind of show you what I mean by twist. One diagonally opposite corner is higher than the other. And that's part of what we have to remove. Now this is hard maple, so there's another attribute to it that we need to pay attention to at this time, and that's tear out. One of the things that you'll run into very frequently on hard maple when planing it or running it over the jointer in a face planing operation or even edge joining is you're going to get tear out. It's just one of those things that'll drive you crazy. And yes, you can get these also with hand planing operations, although not quite as severe or bad, we'll say. Now, how do we deal with this? The same way we dealt with it in our last issue when we were talking about figured maples. I'm not exactly sure what happens when I do this. I don't know if the water is lubricating the cutters or the knives so that they end up cutting through and shearing through the wood better, or if it softens the fibers of the wood. I'm not sure. All I know is it works wonderfully, and it seems very strange that you're going to take this wonderfully dry wood and get it wet, and you would perceive that as adding moisture to it, but it's really, once we shave this off, it's gone, and the moisture content isn't going to go up, the board isn't going to warp and twist severely, and if it does, at least you found out now before rather than after you get your cabinet constructed. So I just spray with a plant mister, a flashing of water over each of the faces before I pass it over the tool. Now, of course, the joiner's got a cast iron bed, water, cast iron, that makes up for rust. I do keep my tools well waxed so that they're pretty well protected, but after I get done with my planing, I'll be sure to wipe it down again. But again, back to the joiner, we'll get one face qualified on all the pieces. Again, paying attention to warp and twist. As I pass it over that jointer, I have to maintain one specific plane across that whole motion. I can't let the board twist or rock. Now that we've got the one face trued up nice and flat, taken out all the high spots, we would put the good face down and run it through our planer. Now what I'll be doing is passing these boards through a number of times. I'm only going to take about 7 to 10 thousandths, 128th of an inch, for each pass. If I try to be too aggressive on the planing operation, there's a good chance I'll introduce more tear out problems. But as I did before, I'll wet down the surface before running it through the machine. Now that I've got both faces of the board flat and parallel to each other, now what we want to do is put a qualified edge on one of the two edges of the board. The joiner, of course, is again the best tool for that. Now when I set up for doing edge joining, I always take my engineer's square and check the fence to make sure that it is in fact square to the table. I never trust the dead stops and so forth that are on the machines. Again, hard maple, watch out for tear out along the edges. If you have to, try wetting it. Watch your grain direction. This particular board that I've got here, the grain's going every which direction, so sometimes you just have to go for it, hope for the best. Well, as you can see, I'm still going through stock preparation. What I'm doing now is I'm focusing on getting the field panels, the material for the field panels milled up and glued up into the blanks that we're going to use to make them. Now what I have to do at this stage is focus a lot of attention on color, on grain pattern, just about everything, every attribute of the wood. Maple often has dark spots in it. Sometimes you can make those work for you. Sometimes they just don't look attractive. So what I have to do is find on each of these boards enough material that when put side by side blends together nicely. I don't want sharp contrasts in either color or grain from board to board. Now unfortunately, I just did a really bad job of selecting out this wood at the sawmill when I picked it up. The colors are going from a yellow to a brownish tan, not only from board to board, but even within the same board. My plan, of course, was to go with a natural finish. I don't think it's going to happen at this point, but I'm still going to continue my efforts to do that. There's also another problem that I've run into on this maple, and you'll see this occasionally. There's some dark banding that's running cross grain on some of these boards. That's called sticker stain. And what causes that, when the boards are put into the kiln to dry, they stack all the lumber up, laying flat, and between each board they put a cross piece of wood, like so. Then they stack them up very high and then weight the top of the pile. Well, sometimes those boards will stain or dye or transfer their color onto the material that's being dried. And I've got some of that here. Now, most of it planed off, but I'm still seeing some of these bands. I don't have enough material, nor do I have enough time. You folks want to see this issue, which is kind of restricting my efforts to get back to the sawmill and pick up some more material. So I'm going to have to try and work with it the best I can. Hopefully we'll find some lessons along the way. So at this point, what I'm doing is working out my lengths of the field panels, finding the best area on each of the boards. Then what I'll do is cut them off to length, joint the edges, and we'll start gluing them up. Now the last step in this segment is to get our panels glued up, clamped up. And what I'm doing is just working one board at a time. I clamp them up, glue them up, clamp two boards together, let that glue take hold a little bit, and then go on to the next and the next and so on. I'm also using liquid hide glue. It definitely dries slower or cures slower, but the one advantage to using this is you won't end up with those raised glue lines. I'm not going to have time to let these glued up panels sit around for much more than, probably a day. Probably by the end of today, I'm going to have to start milling these up a little bit further. So if I was using regular woodworking glue, yellow carpenter's glue or white glue, there's an awful lot of water in there. That causes the glue joint to swell up. The glue hardens with the wood swelled up. Then we go through, plane it off nice and smooth, and then the wood shrinks around that glue over time, a couple of weeks, and then you end up with a raised glue line. Very, very annoying on a piece of furniture that your hand comes in contact with, because you'll run your hand over and you'll always feel that ridge. I've never had that problem with liquid hide glue, so that's why I'm using it. Like I say, I don't have time to let these panels dry any longer than absolutely necessary. Always line up your glue joints before drawing the clamp together good and tight. And we'll let this sit aside to dry until I'm ready to move on. Now, continuing on from our stock prep section, we went through and glued up our panels. Once the glue is dry, we'll go about machining them and so forth. But the one thing you'll notice on the drawings, there are no specific dimensions for the panel size, the exact cutters that we're using and so forth. There's a good reason for that. Now, the cutters that I've got here that I'll be using to cut the stile and rail and the coping cuts and so forth are from Whiteside Machinery. Now, of course, we would highly recommend that you use them. They're very good cutters. Some of you may not have them in your arsenal and you may want to use a substitute. If that's the case, then some of these dimensions would change. So rather than go through specific dimensions and give them to you on a drawing relative to these cutters, I'd rather take a few moments to explain how I go about sizing all the components relative to the cutters. Now, of course, it really does pay to start out by taking some test cuts first and even making up a small panel with the frame components. Luckily, I had done this a little over a year ago for a previous issue where we were demonstrating the techniques to make field and panel doors. Luckily, I found all the parts, so it makes this demonstration go a little bit more quickly. Now, what we're starting with is our stile and rail thicknesses, or widths. We're going with 2-inch wide stiles and rails. So that establishes one of our parameters. The next parameter on the drawings, as you print them out, will be providing the overall width and overall height of each of the door panels. So that'll tell you how big it is relative to the outside dimensions of the frame. And really from there we just figure everything out backwards. Now, as I mentioned, it pays to take your cutters and make up the components. It'll get you familiar with your cutters before you actually have to make a functioning project. But this particular set, there's the cutter set up for coping the ends of your rails, the cutter that does the cuts along the inside edge to create the profile. It also creates the groove to accept the edge of the panel. Then there's the panel raising bit itself that puts the face profile, so to speak, on the field panel. Now the same cutter can also be used to raise up the back portion of the panel. As you can see here, the panel's got a raised section on the back and on the front. And what that does is it allows you to use full 3/4 inch thick stock for your field panel. Now, what we want to do along the process here is get our field panel raised. That's that process of cutting this profile here, fitting inside this frame, but allowing that field panel to grow and shrink with the seasonal changes. And we want the whole structure to be sturdy and preferably not rattle every time you open and close the door. That's where we start from. Now the material that I've got on hand, the moisture content of it right now is at 7.7 or 7.6%. This is where a moisture meter comes in really handy. In my house right now, most of my hard maple pieces are at about 7 to 8% moisture content. All pretty relative. It's also in our seasonal change here right now. We're in the springtime, so things are not quite dry and not quite humid yet. They're in that transitional period. So I know my panel could grow and it could shrink with the next season change. Obviously, summer being more humid, the panel will get wider. So I do want to allow for both contraction of the panel as well as expansion of it. So I need to factor that in on my dimensions. Now let's look at some math. Now here you can see I've got a rough sketch of the door. The outside dimensions, it's 13 1/4 wide by 40 inches tall. The panel or inside dimensions of the exposed field panel will be 36 inches tall and 9 1/4 inches wide. These are given on your drawing. The stiles and rails are all 2 inches wide. So that kind of gives us some of our dimensions. Now with your sample piece, or you can actually measure this right off the cutter, there's another dimension that you'll want. It's the depth of this groove. And that's that key dimension that sort of establishes how everything else fits together. Now this groove depth is just slightly over 3/8 of an inch. But we'll use 3/8 as our working number. So I'm going to make a note of that, 3/8 of an inch. Now, we'll start out with our field panel and get its size. We know it's 9 1/4 inches wide, so I'll write that down. Now, I need it to go bigger than that to fit into those grooves, but I don't want it to go to that full depth. I want it to be 1/8 inch short on each side. So in other words, the field panel projects into that groove 1/4 inch. So I add 1/4 and I add another 1/4 inch on each side. That gives me a field panel width of 9 3/4 inches. I do that same math for the height of the field panel. Now we don't have to worry about the field panel growing in height, but we do want that gap between the details on the edges of the field panel to be consistent all the way around. So it does make sense to allow for that same 1/8 inch gap between the edge of the field panel and the bottom of that groove on all 4 edges. So really, that's the simplest method of getting your field panel size. Now we'll take a look at working out the lengths of the stiles and rails. Now here you can see that 1/8 inch gap that I was talking about. We've got 1/4 or 3/8 total depth of groove. The field panel is going to project in 1/4, and we'll have an 1/8 inch for expansion of the panel. And that's an 1/8 inch on each side of it. Now let's look at the rails and how they fit into the stiles. The stile is your vertical element. Now here's that groove again, and get this oriented right. Here's our rail, and notice that it's going to fit into that groove the full depth. So we know that from this point to this point, we need to have 3/8 of an inch. Same on the other end. So our rail length, the total length of that rail, is the inside dimension of our frame plus 3/4 of an inch, 3/8 on each side. So let's look at that on paper again, and then we're all ready to start working on the details. We know that the inside width of our frame is 9¼ inches. We need to add 3/8 on one side plus 3/8 on the other side for a total of 10 inches. And that's the length of our rail. That's really all there is to it. Working the width and the lengths are the same. The lengths of your stiles, of course, run fully from top to bottom, so they're right off the drawing, no additional math there. The rail, we add on the 3/8 on each end to fit in the grooves, and then the field panel, we make that fill the groove less some amount for expansion and contraction. Now, the reason why I went to the moisture meter was to figure out what stage of moisture content the wood is currently at. If it was very, very wet, I know it's going to shrink a lot. If it's very, very dry, it would expand a lot. Right now, it's pretty much right in the middle of where it should be, so I'm just allowing for an 1/8 inch. That gives me a total width growth of that field panel. It could grow a total of 1/4 inch or shrink a total of 1/4 inch and still not pull away from the stiles on the framing. Before I start milling up all the material for the stiles and rails, I do want to be a little bit careful with the boards that I select and the grain patterns. I'm hoping you'll be able to see this on the television, but this board primarily has grain running horizontally. That's its strongest element. Almost all the other boards, the grain is running very vertical, very straight grained. That is the type of wood that you want to use for your stiles and rails. If the grain is running very coarsely cross-grained, so to speak, with a heavy flame pattern, it's very distracting to the overall visual effect of a door. So try to select the most straight-grained pieces for your stiles and rails. Now, this will be a face frame cabinet, so we're going to have stiles and rails for the face frame as well. Well, in that case, most of that, or a good portion of that, is actually concealed by the door sitting in front of it. So we can use some of the lesser attractive pieces for those components, but keep our better looking pieces up front on the door. So now it's just a matter of picking out the areas that make the best stiles and rails, rip them to width, cut them to length, and joint the edges. Now that I've got all the rails and stiles cut to length, ripped to width, and so forth, we're ready to start moving on to some of the milling. Now the first milling step is actually part of the joinery, and what we want to do is make this coping cut at the end of our rails. Now somewhat that's not the proper procedure. Normally you make this profile cut on the inside faces, but I want to show you a little technique that might work a little bit better for some of you. And that's going to be starting out with making that coping cut first. Now on these cope cuts, the way this is all going to fit together, as you can see here, we're going to create this tongue that's going to fit in the groove that we'll machine in there eventually. That all slides together and creates a nice glue joint that's nice and strong. Now of course, this being maple, or truly this applies to any wood, the coping cut is cross grain, and we're going to probably end up with some nasty tear out on either the trailing edge, depending on which direction. The trailing edge could be either against this profile or it could be against the flat surface. So that's the one challenge that I'm going to be talking about here, is dealing with that tear out. So my plan is to do these cope cuts first, and then we'll follow up with the profile milling as the second operation. Now setting up the cutter, this particular cutter is a single piece unit. What I mean by that is there's one set of cutters all on an arbor to do the cope cut, and then another set of cutters to do this inside profile. Now some of these types of cutters, there's a number of different pieces. You take them apart, switch them around, and so forth. Just be careful with those types of cutters. Now, the way I like my profile to be is I like a strong shadow line along this profile where it comes off the front face It'll drop down with a 1/8 inch deep shoulder, then it goes into the quarter round. Now you can vary the height of the cutter to adjust the amount of depth there. I like a nice strong shadow line there, so I run mine at a full 1/8 inch depth. That will leave me with an 1/8 inch thickness between the back side of the stile and rail and the back edge of that groove, or an 1/8 inch of thickness here. And that balances everything else out nicely for the field panel to make everything relative. So really all I need to do is make that one height adjustment to get that set. And then I'll tinker with the fence a little bit so that my workpiece is positioned properly and I get good dust collection and so forth. Router is unplugged, so I'm not too concerned about touching the cutter. And I'd say based on my original setup piece that I used a number of years back, that's a pretty good set right there. Now we'll adjust the fence in and we're almost ready to start cutting. Now I like to run my fence with this type of cutter, and I adjust the fence so that the bearing is flush with the fence face. So I take my time and get that just perfect. Now when we do our cutting, we're going to be cutting along in this fashion with the face of the board down. Now of course, being narrow, you can't really guide it very well. Now if you have a miter gauge or something that'll fit in your T-slot for your router table, just make sure that your T-slot is in fact parallel to your fence. In my case, it's always parallel because I'm using my table saw's rip fence to adjust the fence position back and forth. And that was also used as a guide to make the slot for my T-slot, so I'm always parallel. But I'm going to be using a sled to help guide the workpiece, keep it square, and to make this operation safe. To make the sled, I picked up a device from Microjig called a Zero Play Bar. And these are really handy devices because they allow you to adjust this bar to fit perfectly in any size T-slot, and you end up with a very precise fitting jig that slides freely but has no play. Now, as I mentioned before, we also have to pay attention to the tear out. We don't want to have tear out to deal with. So I'm going to attach an auxiliary fence to my little sled. We'll pass this over the cutter and that'll create the profile here. That will serve as my backer board as I feed all the remaining rails across. That'll prevent the tear out that we know we're going to have. So I'll tighten these screws up and we'll be ready to go. So we've got our setup. Now all we need to do is pass all of our rails over that cutter with the good face down against the table's surface. What I've done is I've gone through and changed out my cutter. I've switched out to the one that cuts the groove and then the quarter round profile along the inside edges of our stiles and rails. Now what I want to do first, of course, is get the height set, and I'm in good shape there, and then I'll be bringing in the fence. Now you'll notice with both of these cutters, they both have a bearing, and that's actually what you use to guide the work along as you're making your cuts. I like to work with a fence, so I isolate that bearing. I bury it inside the fence just a little bit, or try, if I can, to get it perfectly flush with the fence. That allows me to do a little bit different procedure, and that's what I kind of want to talk about right now. So I'll bring you in close with the cutter and we'll go into some more detail there. Now as I mentioned, both cutters have a guide bearing on them, and that's generally what you use to cut along with. Now if you'll watch, this is the pre-cut one, my test sample. Once I get to this point, the work wants to dive into the cutter. And that's because we've cut away some of the material that the guide bearing would normally follow along. That's why I like to work with the fence. If I bring my fence in, line it up perfectly flush with that bearing, I can feed along like so and not worry about the work diving into the cutter. Now, if I did my coping cut second, if I'm cutting in this direction to do the coping cut, the tear out would be along the flat surface. That's pretty easy. You just put a flat backer block against there and you won't get the tear out. But when we're making the cut in this orientation, this way, the tear out would be in towards the detail or the finish profile. And that gets to be a problem. Now you can work around that by creating a backer block that is in the profile of your tongue and grooves. So your backer block would look like this as you did your coping cut. It works wonderful both ways. I just like to do the coping cuts first so that I got a square end on both sides and it's fast and efficient for me. I know I'm going to be working with the fence anyhow, so that's why I go about that process. If I know I'm going to work with the fence, lining it up, getting it all set up this way is the same amount of work for me. So my next step on this setup is to get the fence lined up flush with that bearing, and then we're ready for some more cutting. Now after your test cut, what you want to do is slide your test cut area in with a coping cut, like so. Make sure that the surfaces are very close to each other or perfectly flush. Make sure everything lines up, and then it's time to start cutting all the inside profiles. Now one last thing I'd like to point out, I'm using my gripper as a push block. I've got the stabilizer plate set up to help hold the work tight against the fence while I'm making the cut, and of course the gripper holds it down against the surface and allows me to safely guide it. I can't emphasize enough the importance of having good safety tools to make any job easier and safer. Well, that wraps up the joinery and the inside profiling. Now we can turn our attention to filling in those big gaping holes between the frame rails. As I've stated in the past, it seems like every project is going to have its challenges. This one just seems to be doing everything it possibly can to prevent me from finishing it. After the panels, these are the field panels for the doors, and after the glue dried, I ran them through the planer again to clean up the faces, and then I finished sanded them. And I happen to notice, you'll probably see, hopefully on the TV here, a dark band. This is that sticker stain that I was talking about. You can see it in a couple other areas. Unfortunately, it's on both sides. This is my good face on this particular panel. Now, it's not real prominent. Now, this is after planing off an additional 1/16 of an inch from each face. I am almost down to 5/8 inch thick. I can't go any more. Well, I could take one more pass, but I know it's not going to get rid of the sticker stain on me. So this project's just going to have to go with a sticker stain. I know I'm going to have to use some kind of a toner, perhaps even a stain to even out the color on these boards. No matter how I did the layout, I just ended up with some dark boards against some light boards. And that's just the way these things go sometimes. If I had time, I would probably get back to the sawmill, pick up a little bit more timber and work that and see if I can't get it to fit in with the project as a whole. But in this case, we're just going to go with what we got. Now the last step, after I've gone through, sanded up the faces, both sides, trimmed them to width, re-ripped them. Now I do want to make sure that these surfaces are all very smooth, so if you can't get a good cut off your table saw, make sure to allow stock for passing it over your jointer. We're also going to next cut them off to their finished overall lengths. We showed you how to calculate those dimensions. So we'll do that next, and then we're ready to do our panel raising operation at the router table. Now to do the cross cutting, it's a little bit wider than my compound miter saw can do, so I'm going to be using the table saw. I've got my cutoff sled set up on the table. Now you'll notice my sled's a little bit on the narrow side. To me, it's just about perfect for the things that I do. But it's sometimes hard to hold the board flat on this end because there's nothing supporting it here. Now I used 1/2 inch plywood when I constructed the base for my sled, so I just keep a 1/2 inch thick shim next to the sled so I can throw that underneath, line up my board, and make my cut. Just makes it a little bit easier. There are two ways to raise a panel. One is to use a vertical panel raising bit. You'd mount it in your router like so, and you'd be passing your boards over on edge. And of course you'd have the cutter buried in your fence. Now these cutters work very good A lot of woodworkers feel a lot safer around them. One, because they're so much smaller. They also require less horsepower on the router, so on a low horsepower router table, these have advantages. I myself have had mixed results with this type of panel raising bit. It almost seems like perhaps it's the species of wood or something, but I generally don't like the finish that I get with this type of cutter as much as the horizontal panel raising router bits. These tend to give me a better finish. As I am working with hard maple, I certainly don't want to have to do any sanding if I don't have to. So I'm going with the larger cutter, and I'll of course make sure it's in there good and tight. And one thing to point out too about these large cutters, you run these at your lowest RPM setting on your router. So it's a good practice to, before changing out your router bits, turn on your router, set it to its lowest speed, then take out the previous cutter and put in this one. That way you won't accidentally start up your router at max speed with this large diameter cutter. That should be about right. What I've done now is just set the router bit height so I can take my first pass. I'm not going to try and do this all in one cut. I'd rather take a number of light passes rather than one great big heavy one. You'll also notice that I put my fence here. I'm not going to be guiding the work against the fence, but rather I'm just using it for dust collection. I was going to use my dust sucker and more, but I lost my adapter between my 3-inch hose and the fitting on this, because this would have worked out good as I could have had it set up on the far side, and it's got a wider throat opening to collect the shavings a little better. Now I'll be guiding the part over the cutter freehand. Well, I shouldn't say freehand, I'll be using my grippers as my guide blocks. I find that these give me a tremendous amount of control, and it's very easy to manipulate the part while making all the different movements and motions and so forth. I can get in here, work the board across, take all the cuts very safely. Now I find that when I want a lot of control like this and I'm doing a lot of various movements, I take and wipe off the bottoms with just plain water. It gives me a little more gription, so to speak. It gives me a little more secure feel. Now you'll notice that when I'm taking the cut, I start out, I'm going to take end grain cut first. I bump it against the corner against my fence, which is fixed, and then I pivot it into the cutter, feed across, work to the long grain, again, bump against the fence first, pivot it into the cut, and so on, working my way all the way around, doing the end grain cuts first and then the long grain. That just stabilizes it when I'm bumping it against the fence like that and pivoting it in. It makes it a more stable and safe cut. Gives you a little bit more control. I'm getting ready for my final pass now to clean up this surface, and I've left about a 1/64 of an inch for that last pass, and that should clean it up nice and hopefully eliminate any steps needed for sanding. Now what I need to achieve at this point is I need this surface to be flush with this surface of my stiles and rails. Now the distance from the back edge of the groove to the front face of the stile is 3/8 of an inch. So I need 3/8 of an inch from this surface to this surface so that both this face and this face line up. I've already made that final height adjustment. Now we'll go from my finished pass all the way around on the front sides of our field panels. Now I'm all done with raising the panel on the front face. Now if my stock was still 3/4 of an inch thick, I would have to do a lot of cutting on the back side until I got this tongue to be 1/4 inch thick. That would work to center the panel inside of our stiles and rails so that the front surfaces would be flush and then the back surfaces would be flush. So you actually raise a panel on both sides. Now as I mentioned before, I had to keep planing down my material to try and get rid of some marks that were on the board. So I'm a little bit more than 5/8 of an inch thick. That means I need to just take a little bit off on the back side. Now in my case, I need to take a 32nd of an inch or 30 thousandths off the back side of my panels. To help me set that accurately, I've used my dial indicator in a holder, and I've got it sitting on the top flute of the panel raising bit. Now I've zeroed out my indicator so that it reads 0 on the table surface. And then by measuring over to this point, I know the difference, and that'll tell me how much of a cut I'm going to be making on the back sides of the panels. Being an old machinist, you just can't part with some of the tools and techniques. And the fit's very nice. It's not sloppy, it don't rattle, it don't slide off, and it's very easy to get it on and off. I don't want to have to hammer this on there. Now keep in mind that that panel will come and go with the seasonal changes, meaning it'll expand and contract. So we do want it to be able to move in there somewhat freely, but we don't want it to rattle, because that's a sure sign of poor quality. At this point along the way, a decision has to be made, and it has to do with finishing, more specifically, the coloring of the wood. Now, as you'll see here on the panels, I've assembled them all and laid them out how they'll pretty much be on the cabinets. As you can see, we've got a dark piece of wood and a light piece of wood, and these are on the same field panel. That's not something I wanted to have. And you know I was very, very careful with my wood selection and so forth. Now, the way cabinet makers deal with these sorts of problems is they spray on a very, very heavy coat of stain. And that pretty much evens out all the coloring, often, of course, changing the color very radically, too. And I wanted these cabinets to just have a clear finish. It's simply not going to happen to keep me happy. Now, if I stain these panels right now as an assembled unit, if this panel were to shrink, the unstained portion, which would be hiding in the groove, would come out and be exposed, and that would just look terrible. So really, you have to stain your field panels before assembly. That's the stage that we're at right now. I have to determine how I'm going to color these field panels, and of course the rest of the cabinet, at this point before moving on. Seeing as how everything else has gone wrong on this project, I figure I might as well try an experiment with the finishing. This is one of those polyurethane products that you get at your home center that has the stain mixed in with the polyurethane. I do need to color this maple, and I do need to get a finish on it. So we're going to give this product a try and see how it turns out. I'll apply a single coat to the field panels, and then after assembly, we'll apply a single coat to the rails and stiles to get them caught up color depth wise, and then we'll apply a couple more coats overall at that time. Now, one of the things that I love are these little rubber balls. You can get them at the woodworking stores and so forth, and they're really, really handy to help keep the panel centered, the field panel that is, centered in the frame. And it also dampens any rattling. So when you open and close the doors, they don't rattle. So that's always a nice thing. But I like to put one at the center of both the rails, the top and bottom, and then I'll put one at each end of the stiles, like on a long door like this, about 3 or 4 inches up from the end. And then that way, when the end piece is on your rail, the little ball or the foam rubber that you put in there will keep that panel centered, but it won't push the panel apart, or the stile, I should say. If I were to put this little rubber ball here in the center, it would try to bow that stile out, and it would look kind of odd because it would have that bowed shape to it. Now we're ready for some glue. Just using ordinary woodworking glue. I'm going to be applying it somewhat carefully. I don't want to put too much on because I don't want a lot of squeeze out to deal with. When I apply it to the stiles, I'll apply it only at about that first inch or so. And then I'll hope that the glue works its way to the other 1.5 inches on the rail thickness. And that just minimizes some of the mess that you got to deal with. Now I will put glue on both pieces. I do want to make sure that I get a good bond, because this joint is really all that's going to hold it together. There will be no additional mechanical fasteners. Stile and one rail together. I'll bring the field panel in. Get that lined up in the groove. Now I'll get the other rail on. Now we can get the other stile on. And I clamp my panels up a little different than most people. I'm going to take it and set it on top of a bar clamp. Get it centered up on there. Now what I want to do is pull down on everything and make sure that this rail and the two ends of the stiles are against the bar clamp. Everything's good and flat down there, and I'll tighten up this end. Now I'll bring the other clamp in. And what I do in this case now is I pull down on the bar, making sure that I'm touching at the full length of the rail and at the two tops of the stiles. Tighten it up, and we're good to go. Depending on the purpose for your cabinet, you'll either use 1/2 inch thick plywood or 3/4 inch plywood for your shelves. I don't have any 3/4 inch plywood. I'm still waiting for it to show up. So I'm going to use some 1/2 inch plywood, and then I've ripped some strips of maple that I'll use for edge banding along the front edges. It's just a 1/4 inch thick, 1/2 inch wide, and we'll glue it onto the front like so. That's really all there is to making the shelves. I'll get some glue along the edge, spread it out so I've got a even coat. Then we place the banding on. Now this next step is purely optional. I'm in a big hurry here, so what I'm going to do to help hold it in place is use some pin nails. These are not brads, these are those very fine pin nails. Now what we'll do is clamp them together with edge banding against edge banding. That will even up that clamping force to make a nice even clamp pressure along the full length of the edge banding. As you can see, I finally got some plywood. Not exactly what I wanted, but it'll do. Now it does have two good faces on it, so on the components that will be exposed or visible from both sides on these plywood pieces, at least I'll have some decent looking material. The species of wood that I've got is somewhat suspect. I'm not exactly sure what it is, but it will pass for maple. Now when I picked it up from the mill, I had them cross-cut the sheets into lengths that were suitable. That just saves wear and tear on my body and back. I'm getting older and I don't like hefting around big plywood sheets if I don't have to, even though I've got a panel saw right here in the shop. Now to make the finishing process go easier, what I decided to do was to apply a finish coat to the plywood panels before I cut them up into smaller pieces. The reason for that is, whenever you're spraying or applying finish on the inside of a cabinet, you're working in very confined areas and it's very difficult to finish. So by pre-finishing the material now while it's in large sheet form, I save myself a lot of work when I go to do the finishing when the project is completed. In other words, the inside of the cabinet's already finished. Now of course, just select the finish that suits your tastes. Water polyurethane, oil-based polyurethane, shellac, lacquers, whatever just works for you and what you're comfortable with. Now as you can see, I'm going through and ripping the pieces up into their overall dimensions. I'm going right for size. You'll notice that when I was cutting up these panels, after the last final few cuts, there was very, very little material left. At 15 7/8 of an inch wide, you just get 3 equal pieces out of it. If I would have went just a little bit bigger on the drawings, well, you'd have had a lot more waste on your plywood. But in this case, it works out very good. We've got nice yield out of the plywood panels. And again, here's the finished material, and you can see the plywood before the finish is applied. And this, of course, will go on the outside. This will be my inside face. Now I'll go through, rip up the rest of the plywood pieces, and then we can move on to some assembly. As you can see, I've moved my fence to the left side of the saw blade, and I've installed my 1/4 inch stacked dado head cutter. What I want to do now is go through the process of cutting the 1/4 inch wide grooves along the inside faces near the back edge. That will receive the 1/4 inch thick plywood back panel. The setup's very straightforward, 1/2 inch between the fence and the dado cutter, and raise it up 1/8 of an inch, and just make sure you pass the right pieces over in the right orientation. And we've got that at 3/4 of an inch. Now what we need to do on our cabinet side panels, 3/4 of an inch up from the bottom, down from the top, we need to create a 1/2 inch wide dado that will accept the top and bottom panels. Now, of course, in the smaller cabinet, you'll have that extra intermediate shelf that has to go in as well. Now, before we can do assembly, there's one more step that we have to get out of the way, and that's to drill our shelf holes. Now, there's a variety of different methods of doing this. There's jigs that you can purchase, shop-made jigs. We presented a shop-made jig. I believe it was very early on, maybe around issues 2 or 3 or something like that. We had done some shelf hole drilling, and we had either presented a jig for how to do that, or it was just one of those very simple jigs that really only required a few pieces of wood and you were all set to start drilling shelf holes. I was going to show you how to use that jig again, but it's missing in action somewhere. I seem to have lost it somewhere here in the shop. So I decided, rather than try and make up another one, because we're so tight on time for this issue, I'm going to use the next best thing. Well, as we've presented a few times before in the past, the CNC router comes to the rescue again. In this case, it only took me a couple minutes to set it up and write the program to drill the holes for the shelf standards, but it sure handles that repetitive work very gracefully. And I'm kind of glad I'm not sitting there drilling all those holes. Now that we've got some shelf holes drilled in here, we can start some assembly. Now I'll be using primarily glue to hold everything together. You'll notice that I'm putting glue in the groove that accepts the plywood back panel. So yes, I am gluing that in. Now we can bring in the back panel, get that somewhat started in that groove, and bring in the top piece. Now we can put on the other side panel. Then we can bring in the two bottom panels. The one is the shelf, the other is the bottom of the cabinet area. Now this step really isn't necessary, but I find it helps out a little bit, keeping everything in alignment while I clamp things up. And that's to just drive in a couple of brads at each corner. That ties everything together and helps to keep it somewhat straight and square while we clamp it up. Now what I'm doing is, of course, checking for square. Both these measurements must be the same, and I'm out almost a full 1/16. We'll just give it a little push, see if that brought it in. If not, I'll throw a clamp on here. Nope, we're in good shape. Now you'll notice that with our construction technique, this plywood panel fits into a groove on that top shelf. Now normally when a cabinet is attached to the wall, you screw through the back panel into the studs in the wall. So realistically, the entire weight of the cabinet is supported by this back panel. Now near the bottom edge, all we're really doing is going to tack this in, or tack that back panel to the bottom shelf, somewhat like how you'd construct a drawer. All the weight is transferred up to this top shelf, which transfers to the side and supports the entire load. So some small brads and we'll be all set. And we'll just clamp this up, set it aside to dry. And I should point out that the large cabinets assemble the same way, they just don't have this extra shelf in the middle here. That should work out pretty good. As you can see, I'm turning my attention now to the face frame. The face frame is actually quite simple to construct and to attach to the case. I'm not going through the laborious process of using pocket hole screws through the side panels and then into the face frame. Personally, I don't think it's really necessary. Some folks feel that it is. It's strictly up to you how you want to go about that. But what I do like to do with my face frame is I like to put a dado or a groove on the back side of it so it fits over the plywood edge, sort of encapsulates it and unifies the two components together, the face frame to the carcass. So we'll go through the process right now of getting it to the point where we can cut the dados, fit up our stiles and rails, and get the face frames assembled and then attached to the carcass. Now we can turn our attention to the face frame. Really, this is probably hopefully going to be the simplest part of this project if no more problems pop up. All we really need to do is have good straight timber to work with, ideally straight grain so it looks attractive. Of course, joint one edge of your boards before ripping so that you end up with nice straight pieces, because you don't want to have bowed or cupped or warped or twisted pieces for your face frames. But realistically, just rip them to width, cut them to length. Now, of course, you do want to watch your lengths very carefully, because if they're varying in width for your rails, your cabinet simply won't be square. Now we'll just start ripping away. And now we'll go ahead and cut each of the pieces off. You'll notice that I'm using a stop block. That will assure that I've got good consistent lengths on each of the rail pieces. Now I'm still using the same 1/2 inch wide stacked dado head cutter I used when I was cutting the grooves and dados in the plywood panels. However, I've shifted my fence over. The one critical or somewhat critical dimension is the 3/4 inch distance between the dado cutter and the fence. That will establish the width between the stiles and the rails. So you do want to be careful with that. If anything, favor it to the long side, and that will actually push the two stiles a little bit closer towards center, meaning that your rails will be a little long. And then you can always trim them up during your fitting process. But raise your stacked dado head cutter up about 1/8 of an inch. Its height isn't real critical in this application as long as you're consistent for all your pieces. On your stiles, you want that 3/4 inch wide section from the groove to the edge to go towards the inside of the cabinet, like so. This would be my 3/4 inch area. For the rails, you want that 3/4 inch area to go towards the outside. Now at this point, you can see the parts don't fit up yet. What we have to do is mark the location at this intersection, because the bottom and top shelf extends across the grain coming out this way. So what we need to do is now create another groove or dado, just a short section in this area to accommodate the bottom and top. To do that, I'll just lay it on the cabinet, line it up flush top to bottom, and then I'll take a pencil and mark those locations. Now I'll bet you thought I was going to pull out the router to do that. It really doesn't make any sense to make up a jig or anything else to remove that small amount of material. This is nothing that a couple of bench chisels and a mallet can't fix very quickly. Now here you can see that cross dado we just cut. That fits over the top and bottom, and then the outside edge, of course, fits over the outside. Now we can put in our top rail, and that ties everything together. But we do need to come up with a way to join our rails to our stiles, and we've got a nice tool for that as well. One of the best ways that I've found to assemble face frames together are these pocket hole screws. It's a very fast, strong, and efficient system to use. I've got a Craig system here. Works out quite simple, quite easy, and it does work very well. It's also very simple to use. Line up your piece with the holes on the one side of the jig. In this case, we're using the 9/16 inch spacing. Clamp your work in place and drill your two pocket holes. You don't have to be precise on the alignment. Now, as you can see here, I've got my two pocket hole screws, but one of them ended up lining up inside my groove. And after I drove the screw in, I noticed that the head of it is going to stick out too far. And that'll prevent this piece from going down against the top or bottom shelf. So I'm really not going to worry about it. I'll just use one screw, and I'm more than confident everything will stay together fine. Now, as you can see, I've got all my pieces laid out on the workbench here. What I'll be doing is applying some glue to the mating surfaces. Even though it's end grain, that glue still will actually help. Then we'll just drive in the screws. Now, to help hold everything in alignment, these pocketing jigs come with a vice grip type device that helps clamp everything together and hold it in proper alignment so that your faces are nice and flush. So we'll start on the assembly, and then we can put this on the carcass. Now, if time allows, you can apply a thin film of glue on this end grain and let it come to near dry. Then apply another coat and then assemble it. Back in the days when I did model airplanes, when I was a kid, we used to call that pre-gluing. And I don't remember the name of the glue that we used at that time, but that was a requirement. You had to do pre-gluing before you glued two pieces together. Otherwise, it just simply wouldn't bond. Now, you do want to make sure that your groove is lined up, because that's actually the most important aspect at this point. We clamp it, put our screw in there, and tighten it up. And that's it. We repeat that on the other three corners, and then we'll go on to the center rail. What I'm doing now is laying out a location where the center stile is going to go. It'll fit in here like so, and I just line it up between those two marks. And of course, we'll drive it in with some screws. Now you'll notice that the center stile is 3 inches wide, so I could get 2 pocket hole screws on there. So we'll get some glue, screws, and then we're almost done with the case assembly. Well, the dry fit went real well. What I'll do is pop it off, apply some glue, and we'll put her right back on again. A few clamps and we'll be all set. Now with the door frames all glued together and everything assembled, the last step that I want to do is to mill another decorative element around the front edge. Now I want this outer element to somewhat mirror this inner element here, which is a 1/4 round and a small shoulder. Now I'll just be using a 1/4 inch radius roundover bit. It's a white side bit, part number 2005. I'm going to do it here in the handheld router just because it's a little bit more convenient, especially for the longer panel for me. If I had a 1/4 inch shank router bit, I'd of course do it in my trim router, but I don't, so rather than use a big heavy router, I'll just set everything up in the router table. Well, looks pretty close. I think I'll go a little bit deeper on that shoulder. And I think that does the trick. I could go up maybe one more size on the roundover, but I think that just gives it a nice clean look. And now we can move back to finishing. Now I do have to be somewhat careful how I apply this finish. I don't want to get too much in here and have it puddle in these areas. But I also, of course, have to get the finish where I need it. So we just very carefully brush it in. You'll notice this time I switched to a smaller brush, and it's got that angled tip on it, so it helps me get into these areas a little more precisely. But I'll just go through, brush on my finish like I did before. I'll probably get about 2 coats on, maybe 3, and then we'll see how it looks before going on any further. What I'm doing now is going through and laying out the location for the hinges. Now I had originally planned to go with an exposed hinge, but have changed my mind. Now I'd like to point out too that the finish isn't quite dry yet, but I'm just trying to hurry up and get these things finished up so we can get this issue out the door. Now normally what I would do at this stage of the game is get everything polished up. I usually polish my furniture objects with 4/0 steel wool and some wax, and get everything finished up real good that way. I haven't yet had a chance to do that step, but I am doing the hinge installation, and with the tall cabinets that are 42 inches tall, you should go with 3 hinges. You can probably get away with 2, but in practicality, go with 3. It just makes the system function better and makes it more durable. Now, as you can see, I'm using the concealed hinges. And for the two different cabinets, I'm actually going to use two different types of hinges just to demonstrate the different overlay effects. Now, this door happens to be a 1/2 inch larger than the opening on all sides, but I'm using a 5/8 inch overlay hinge. So that means that this side will overlay this stile by 5/8 of an inch. Now, the smaller cabinet, which we'll get to in a moment, I'll explain that 1 3/8 inch overlay. Now, the instructions for installing these hinges are somewhat unique to each brand of hinge. These particular ones, they come with a little drilling template and everything to make it very easy to do. But they do get mounted in the stile using a 35mm Forstner bit. So you're going to bore a large hole in there and then drill for your mounting screws and get them attached here, and then we'll attach them to the cabinet. So next up, we'll get over to the drill press, get our holes drilled out, and then we'll pay some attention to the smaller cabinet and then the specific hinges. Just make sure that you drill only as deep as necessary and don't drill through to the front side of the stile. Then mark your holes, drill your pilot holes for the screws, and mount up the hinge. What we're going to look at now is the overlay factor. Now, this particular door I've just got laying on here, and it's got 5/8 of an inch overlay. This is the type of hinge that I used on the larger doors. That clips around like so. This portion attaches to your rail, and then we bore a 35mm hole in the back of the stile to accept this portion. Now notice the offset distance there. Now when we go for these small doors, I set them up for a larger overlay. Notice now the difference. This one is shifted back further. We'll get the other one in position so you can do a comparison once I get my orientation right. Now you get an idea of where that overlay comes from and how it figures into the hinges. So you have to take into account your hinges along with your door sizing and so forth. Now, as I mentioned, these will be a 1 3/8 overlay, so there will be an 1/8 inch distance from the outside edge of the stile to this edge of the door. Now, if you're making a series of cabinets that all fit together side by side, you have to watch for this clearance, because as the door opens, you have to make sure you've got enough room in here to allow for that door to open. Now what I'm doing is setting the height, or the vertical position of where I want the door. And with this particular type of hinge, it just kind of hangs there, which makes it nice for marking the hole locations. So I'll mark those, drive the screws in, and then we're done. Now you may often wonder what to do with all those extra scrap pieces of plywood you have after making cabinets like this. Well, with this type of cabinet that gets hung on the wall, I cut them up into strips about 3-4 inches wide, and I use them as filler stock between the 1/4 inch back panel to the edges of the 1/2 inch plywood panels so that it's a flat surface. And I'll use that area where I'll drive my screws from the inside of the cabinet through the 1/4 inch back panel, through these strips, and then into the studs of the walls. That makes for a much more sturdy and secure mounting system. So I just get some glue spread around and stick them in place. And if needed, put a couple of weights on there till the glue takes hold. In spite of all the troubles that we've had going through the construction of this project, I must say I'm rather pleased with the final result. Now, I guess this word of advice, order your materials plenty of time in advance, take your time, and don't rush. Things often go much better when you're not rushing. I'm Chris DeHut for Woodworking at Home. Thanks for watching.